Let's study 9th standard ICSE Physics, Chapter 4A, Numericals. Pick sums number 2, 4, 7, 9, 11 and 13 and mark the following sums as IMP. The second sum, 7th sum, 11th and 13th. They are IMP. You have to solve the solved examples. 2. In the solved examples, cancel the 7th solved example and the 10th solved example. Now in the second sum, they've given the mass and the dimensions, that is the volume, and even the base area. Calculate the thrust. Thrust is a normal force, that is a perpendicular force to the surface. In this case, it is the weight. Usually thrust is the weight. So thrust is equal to weight, and the formula for weight is m into g. Mass is given. G was also given, although indirectly. If they said take 1 kgf as 10 newtons, so they are saying that the acceleration due to gravity is 10. So that's the value we will take here, and the answer is 75 Newton. The next question is find the pressure. Pressure is thrust upon area. Thrust we found out. Now the area is given as 12 into 8 centimeter, but since we are dealing with SI units here, it's important to convert this to in SI units. So this will become 0.12 meter and this will be 0.08 meter. To convert centimeter to meter, divide by 100. So these dimensions of into 10, the height was of no use in this sum. So we substitute the value of the area here. So that's Newton upon meter square. This is the answer after solving further. Yes, you need to solve it further. Don't just copy. You need practice of multiplication division. And the answer, either you can write Newton per meter square or you can simply write Pascal. Next, the fourth sum. Now the area of the base is given. The density is given and the height is given. Calculate the pressure. Now pressure is thrust upon area, but here area, we have the area but we don't have the thrust, which in fact they have asked in Bravo. So if you wish, you can find the thrust first, that is the weight. Now for weight we need the mass, and mass is volume into density. The density is given, and you can find the volume, that is area, into the height, but that is in centimeters, so you'll have to convert into meters first of all. So that's a very long process. So let's go for a shorter process, a shorter formula. Pressure is H rho G. Simple. Pressure is H rho G. We are talking about fluid pressure, isn't it? Height is given as 6 centimeters, so we convert that into meters. Conversion is very important in physics. One of the top silly mistakes which students do is conversions. And second silly mistake is the units in the end. Rho is density. Density is given as 1000 in SI units, and G is also given as 10. So just substitute the values and get 600 Pascal as the pressure. And thrust, after cross multiplying this formula, thrust is equal to pressure into area. Pressure we have calculated. Area they had given as 300 centimeters square, but we have to convert it into SI unit. So how do we convert centimeter square into meter square? Divide by 10,000. That is, divide by 100 and divide by 100, because it's centimeter squared. So we'll have to divide by 100 twice to get it into meter square. So then what's the use of density? No use in this sum. Next, seventh sum. A simple U-tube. Yeah, a simple U-tube looks like this. What do you mean by simple U-tube? Well, this is just to differentiate between a simple U-tube and a more complicated U-tube like this one. This is a complicated U-tube, but this is a simple U-tube. So it had mercury, so initially the mercury levels were same in both the arms. If water is poured to a height of 13.6 centimeters in one arm, how much will the rise in mercury level be in the other arm? So obviously if I pour some water on one arm, then it will push the mercury onto the other arm. But by how much height will it rise? It won't be the same, because you see the density of water and mercury is different, so even the pressure is different. Now we know that the pressure on the left arm exerted by the water should be equal to the pressure on the right arm exerted by mercury. The pressure has to be equal as per Pascal's law. And pressure formula is H rho G, H rho G. G and G got cut. Height H1 is given 13.6 centimeters. Density is given as 1000 kilogram per meter cube. Note that this is in SI unit and this is in CGS unit. That's okay. If you don't convert, even if you convert, it's fine. But if you don't convert, it's fine, because what matters is the density here and the density here should have the same units, which it is. The density of mercury is also given in kilogram per meter cube. So if I leave it as centimeters here, then I will get the value of H2 also in terms of centimeters, which is 1 centimeter. Don't forget to write the final statement. I've just put a dot, 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 but you have to write the final statement. Don't be lazy. No, I'm not lazy. I'm just trying to save ink. Ninth sum. What should be the ratio of area of cross section of the master cylinder and the wheel cylinder of a hydraulic brake, so that the force of 15 Newton can be obtained at each of its brake shoe by exerting just a force of 0.5 Newton on the pedal? So always read the whole question properly before solving the sum. Hydraulic brake, if you remember, was shaped like this. We exert a force out here which creates a pressure, and this pressure is exerted here. But here, which is the master cylinder and which is the brake cylinder? Remember, the master cylinder is the one on which we have to apply lesser force. And the brake shoe, on the brake shoe, a greater force will be applied. But remember, the pressure is same. A smaller force is getting multiplied into a greater force simply because the area of the brake shoe is greater. And of course, the speed will decrease in this case. So it's not something magical here. So we'll use Pascal's law to solve this sum, which is F1 upon F2 is equal to A1 upon A2. So F1, let's assume that's for the master cylinder, that is the input force, and F2 is the brake shoe force, which is the output force. So be very careful while reading the question to understand which is the input and output. Input obviously has to be smaller than the output. That's the whole point of using machines. Less input, more output. So the ratio of the forces is the ratio of the areas, and that's what they've asked us to find, the ratio of the areas. But make sure write it in the form of a ratio, not a fraction. Next, the 11th sum. Read the question. The diameter of the neck and bottom of a bottle is given 2 centimeters and 10 centimeters respectively. It's filled with oil, and the cork on top is pressed with a force. What's the force at the bottom of the bottle? So it's better to draw a diagram to understand this sum. So the neck's diameter is 2 centimeters and the bottom's diameter is 10 centimeters. There's a cork out here. It's filled with oil totally. And the force on top of the cork is 1.2 kgf. What will be the force on the base of the bottle? Now, since the area has increased, definitely the force will also increase, but the pressure will remain same. So as per Pascal's law, force upon force is equal to area upon area. So F1 is 1.2 kgf, F2 is unknown. And area, they have not given the area, but we know it's a circular area, isn't it? The base of a bottle. So it's three-dimensional. It's a circular base. So that's pi r square, that's the formula, right? So the radius for the top circle is 1 centimeter. This is the diameter. And the radius for the bottom circle is 5 centimeters. So that's pi and pi gone. That's 1 squared upon 5 squared. That's 1 upon 25. Cross multiply and get the value of F2, 30 kgf. Please write the final statement as well, without which you lose half mark. And in Bravo, they've asked which law have you used? We've used Pascal's law. Now the 13th sum. There are 2 cylindrical vessels fitted with pistons A and B. Their areas are given and the mass on one is given and the pressure on both is asked. So for this, you may refer to this diagram here. So we've got piston 1 and piston 2. The areas are given. A1 is 8 centimeters square and area number 2 of piston B is given as 320 centimeters square. The mass on the one of the pistons is given. So question number 1 is, what is the pressure on piston A? Well, pressure is thrust upon area. Thrust means the weight, and weight is 4 kgf. You see, if the mass is 4 kg, then the weight is 4 kgf. If they would have given the value of g, then we would have found the weight by the formula mg, like this. And assuming g as 10, then I would have said that the weight is 40 Newton. And I would have got the answer in 40 Newton per centimeter squared. I could have even converted this to meters squared. But there's no need to do all this, because they've not asked for anything like that in the sum. So let's leave it as it is. 4 kgf upon 8 centimeters square is 0.5 kgf per centimeter square. Roman number 2 is, what is the pressure on piston B? Well, as per Pascal's law, it's the same. So let me write here, Pascal's law. You need to write reasons and laws wherever applicable in numericals. And the third part, they have asked for the thrust on piston B. Well, pressure is thrust upon area. They have given us the area. We've calculated the pressure, cross multiply and get the thrust. 160 kgf. Wow. That means you are applying just a 4 kgf weight or thrust on piston A, that is the input, and the output is that you can lift something of 160 kgf. That's the beauty of hydraulics. You get more output than the input simply because the area is great. However, as you know, that this is nothing extraordinary or against some laws. It's just that the speed will be slow. The object will be lifted very slowly.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.